Hello and welcome to this IxNetwork video tutorial on the new feature called NextGen Protocol Framework, introduced in IxNetwork 7.0, also known as NGPF. This feature is a new framework for protocols that IxNetwork already supports and will support in the future. As you can see in the screenshot here, the new framework is very next-gen, not only visually, but in the way that protocols will be built and used by our customers' next-gen products and their customers' next-gen networks. Here's the agenda for this IxNetwork video tutorial. This video tutorial will be broken up into 5 chapters, each chapter going into different aspects of the next generation protocol framework. Chapter 1 is just a few slides on what is NGPF, why did we decide to build a new framework, and what are its benefits to our customer base. Chapter 2 goes into the new NGPF terminology. There are some new terms that go along with NGPF, and it's very important to understand them when you get into the GUI itself, which is chapters 3, 4, and 5. Chapter 3 is where we start to configure protocols in the next generation protocol framework using IxNetwork. How to add them, how to modify, how to use the predefined resources, scaling, customizing, etc. Chapter 4 is where we start the protocols and we look at the per session status, the device group status, the color coding, red, green, and yellow, and basically what are the new statistics in real time, and how do we drill down into the protocols to look at per session stats. And finally, in Chapter 5, we'll be showing you how to build traffic using NGPF endpoints in the Traffic Wizard. There's a new endpoint selection tool specifically for NGPF endpoints, and this chapter will show you how to use that feature. In this chapter, we're just going to cover a couple slides on what is NGPF, why did we build this new framework, and what are its advantages to our customers. So what is IxNetwork NGPF? Again, NGPF is a new protocol framework. They are not new protocols. They're the existing protocols we already have in IxNetwork, except we've migrated some of them at this point to the new protocol framework. It's definitely an upgrade to the framework. We have a lot more flexibility, a lot more ease of use to scale, a lot more granular control, a lot more control at a range level, what we call a device group. This framework was definitely built to meet and stay ahead of our customers' requirements in terms of protocol stacking, in terms of building real-world networks with a visual representation of those networks. So we're moving into the next gen protocols and technologies, and this framework will help you get there. Definitely designed to provide consistent workflow across all protocols, whether you're doing broadband or you're doing routing or you're doing IPv4, IPv6, DHCP. It's a consistent framework for all the protocols, and they're all going to get the benefit of the features that the framework provides. And again, designed to work more closely, simulate dynamic customer environments, so more stuff in real time, dynamic changes, and again, a lot quicker to configure and get a network to that next gen scale. Okay, the next question might be why a new framework for IxNetwork? What was wrong with the old one, or why did this need to be done? Well, the current IxNetwork protocol framework is not optimized for ultra high scale. It does not scale well. You can only have so many protocol interfaces, and the GUI starts to become sluggish. High port counts, high scale. The new framework is definitely more optimized for much higher scale, a small footprint environment as far as memory and CPU, and again, the scale is definitely next gen. The framework is not flexible or realistic. Currently today in IxNetwork, with the existing protocol framework, we can't stack protocols very well. All the protocols have to be configured in a silo, OSPF by itself, LDP by itself, BGP by itself, and we cannot emulate true dynamic behavior, subscriber behavior, like in a broadband environment where you start the sessions and you start the traffic right away. So this new framework takes care of all that, where we have the stacking in a visual environment for true real-world emulation, real-world subscription, and it does a good job at that, as you'll see. The current framework is about 8 years old now, so while it does do well as it works today, we needed to do NextGen for NextGen protocol stacking, NextGen networks, and as our application traffic over routes needs grow, we needed a new framework for that. So this framework will definitely take care of that. And then the current protocol has an inconsistent workflow. The routing is configured and looks a whole lot different in the GUI than the access. Well, the new framework combines all the protocols into a single consistent workflow, a consistent feature set, and it's able to suit the complex test scenarios that the existing previous workflow and framework could not. Okay, and lastly, what does this all mean? What are the key building blocks of NGPF, and what are the benefits? Well, you definitely have the visual element, which you're going to see in the next chapter where we get into the GUI. You're going to see a visual representation of all your protocols, and if they're up or down, and stacking and all that stuff is in a nice visual environment. Consistent workflow we talked about of all the protocols. A new framework obviously would provide that. Topology-based configurations to reduce the application learning curve, so you can see and really feel your different protocols all working together to understand the topology. Scalability, we can achieve up to 100% improvement in port scale, and then at least 50% improvement in protocol scale per test. So a lot more performance for our protocols in this new framework. And we also reduce the memory of the client machine that runs the IxNetwork GUI by 30% with the new protocol frameworks. Very flexible protocol stacking, granular per session control, as well as range concepts. So you get them both all at the same time. System level stats, you get dashboard. Again, this framework will allow a truly converged layer 2 to 7 environment for testing, dynamic control plane protocols, and bringing them up and down in real time, and provides the framework for more dynamic traffic control for real world traffic. Okay, in this chapter we're going to cover NGPF terminology. This is a very important chapter to understand for those that we will be using the IxNetwork GUI and the new next generation protocol framework, because it really helps you with the building blocks of how the new terminology results in a visual representation of your network, as well as those same elements are used in the configuration. So you're really going to need to get to know them to use the NextGen protocol framework. The first highest level of NGPF in the IxNetwork GUI is the scenario view. So in the new starting in 7.0, you'll see this scenario view on the left hand side of your screen, and it basically represents the entire NGPF section of the GUI. Note that you'll still have the existing framework in the IxNetwork session. We're not getting rid of that. We've just labeled it Classic Protocol Framework, which is your existing OSPF, BGP, LDP, and everything else. But we now have the new scenario node, which will house a next-gen protocol framework that you can use for the protocols that are supported there if you like. So you really have a choice. You can use the new next-gen protocol framework, the classic framework, or both. The only caveat, if you're going to use both, is that you cannot run the next-gen protocol framework and the classic framework on the same port at the same time. But if you separate them via ports, you can run both at the same time in the same IxNetwork session. You just have one scenario, and in that scenario you'll have multiple topologies, device groups, etc., and we'll get into those terms in a minute. It can have one or more topologies, as shown here. There's 4 topologies of different protocols in each, and again, you can only have one scenario per test. The next 3 slides are the 3 main components of protocols using NGPF. They are topology, device groups, and devices. The topology as shown here is the highest level, and inside the topology are the device groups and the devices. A topology is basically a block of similarly configured ports. The key word here is similarly. All ports in a topology by default are all running the same protocols and the same number of devices per protocol. The details of the devices can be unique, such as addressing and protocol specifics, but the number of the devices and the protocols running on each port are all the same. The advantage here is quick, easy, and scalable configuration for like ports. Examples are broadband subscribers, CE routers, or IP/multicast hosts. If any port needs to be unique, just put it in its own topology. The example screenshot here, there are 4 ports, each with 20 routers for a total of 80 devices. In this case, the device group is a stack of OSPF routers, so in this case it's 80 OSPF routers. Each of those 80 OSPF routers has 10 devices per router for a total of 800 routes or IPv4 prefixes. So that's how a topology is built. I can add more device groups to the topology if I want. I can change the multiplier, we'll get into that later, and I can also add and remove ports to the topology. Inside the topology you have device groups. A device group represents a logical group of devices and a role for those devices, such as hosts or routers. Each device group consists of a protocol stack. As you can see highlighted here, we have our OSPF stack highlighted. That could be a PPP stack or whatever you want it to be. You just have to have the right building blocks to build whatever protocol you want. And then, of course, within that device group is one or more devices or sessions. In this case, the multiplier here, which we'll get into later, signifies there are 20 devices per port. So in this device group, it's 80 devices across 4 ports and 20 devices per port. And then as you can see, if you click on in the GUI, as we'll see later, if you click on the device group itself, you'll see the configuration grid at the bottom, and you'll see the device, the Ethernet stack, the IPv4 stack, and then the OSPF router and its interface, all in different tabs. You can also see how within the first port here in the screenshot at the bottom, you can configure every device with unique parameters and characteristics via the configuration grid. And then within the topology, within the device groups, are the devices themselves. Each device represents a per session within a device group. As mentioned earlier in the topology slide, the devices are configured on all ports assigned to the topology, and each session can be independently controlled. As you can see in the screenshot below, you get the per session row. Each session can be started and stopped. It shows you a status information field, interface state, and OSPF neighbor state. So each session can be controlled individually, or at the port level, or at the device group level, or at the topology level, or at the test level. So there's plenty of control from the highest level to the lowest level as far as the protocols and devices using NGPF. Okay, and the last slide here before we get into the GUI in the next chapter is the terminology for multiplier and network groups. The multiplier is a scale ratio for devices within a device group. So as you can see on the right hand side here, the number of ports times the multiplier equals the number of devices within the device group. So in this case there's 2 ports, there's 50,000 devices per port for a total of 100,000 devices. In this case they're IPv4 devices because this is an IPv4 device group. So as you can see, it's very quick and easy to scale just by clicking on this box, changing the multiplier, and next thing you know you can scale from a few hundred to thousands and even hundreds of thousands is what's supported. The next term here is network groups. Network groups is basically route pools, IPv4, IPv6 route pools. They can be advertised through the protocols like OSPF, and of course the route pools can be used by multiple protocols. As you can see here, this is kind of like route ranges behind the routers themselves, and you can see at the bottom of the grid here where you configure the route, the starting address, the routes, and the ending address. Okay, in Chapter 3 we're going to get into the GUI and learn how to configure protocols using the NGPF framework. We'll show you how to add protocols, modify them. We have some predefined resources that you can just drag and drop into the scenario view. We have some new rate options with NGPF, and show you how to customize and scale your configuration using a new pattern tool and the multiplier. Okay, here we are in the IxNetwork GUI, And starting in IxNetwork 7.0, we now have the scenario button here for the NextGen protocol framework. So you can go inside the NextGen protocol framework. I've already minimized the statistics so we don't have that window pane shown. That way we can focus on the visual representation view up top as well as the configuration elements down below. So to add ports and protocols into the scenario, you can either go back to home and add ports the way you did before, or you can go into new topology and add ports from here. Click on our chassis, highlight the ports we want to use. In this case, I'm just going to add 2 ports for now, and I'm going to move them over into a topology. And next I pick on which protocol do I want in this topology for those ports. So I'm just going to select IPv4 as a good example. You'll see the list of current protocols that are supported in NGPF. There are much more coming from the existing framework into the new framework. This is just a list as of right now. So as soon as I click Finish, I'm going to see that 2 ports, Ethernet 1 and 2, were put into a topology called Topology 1. It's important as soon as you add topologies and device groups that you name them. This will be useful for the configuration grid as well as when you get to the traffic wizard. So I'm just going to call it my IPv4 topology 1 and my IPv4 device group 1. So what's been created here is my 2 ports. By default, the multiplier is 10. As you can see here, when I click on my device group, I see I have the devices itself, and I can enable and disable per device. I have the Ethernet layer, which I have shown me both ports and unique MAC addresses per port, and I have the IPv4 layer with some default addresses. In addition to clicking on the device group to navigate through the grid, I can also click on the stacks themselves, the Ethernet stack, and I can just see the Ethernet stack or the IPv4 stack by itself. But in this case, I kind of like to see the device, Ethernet, and IPv4 all together. On the left-hand side of the screen, you can also see where we have all the NextGen protocol stacks. So in this case, I only have Ethernet and IPv4 configured in the scenario view, so those are the only 2 stacks I will see. But if I also have DHCP device groups or OSPF device groups and topologies, I'll see those stacks as well. The difference is when I click over here on the left-hand side, I'm not going to see the scenario visual picture at the top. I'm just going to see the configuration list for not just one topology and one device group, but for all topologies and all device groups for all stacks. So here's my Ethernet stacks for all topologies and all device groups, my IPv4 stacks for all topologies and all device groups, and again, I also have the configuration options at the top to configure them this way for all IPv4 stacks in the test versus the scenario view where I can just configure the one stack in the one device group at a time. Another very nice way to add protocols and topologies into the scenario view is simply by dragging and dropping them. On the right hand side of the screen that comes with IxNetwork are some resources you can just drag and drop. We actually have one resource for all the protocols that are currently supported. You can see the DHCP client server. We have IPv4, IPv6, autoconfig, and OSPF and PPPoE. So the way to do that is just drag and drop. Now for the demo, I'm actually going to pull up a new config and then drag it in to show you how that works. Okay, so we have a new config, so I'm just going to come down here to the same IPv4 resource and just drag it and drop it. The nice thing about these resources is once you have them and have saved them, you can just do that via the resource manager on the top here. Just do a save, and they'll be added over here into the right-hand window where you can just drag them and drop them in the future. So once you have a topology you want to save or a group of topologies, just save them off as a resource and pull them in anytime. Now in this case, the one I pulled in has 4 ports, offline ports. So let's just add online ports to these offline ports, and we can get started. Go back to scenario. You see the ports come up here. There's some color coding going on, and now we have a device group with 4 ports, 40 MAC addresses, and 40 IP addresses. But now with those 40 addresses, we can see that they may not actually have the right IP addresses to actually work with the DUT. So the next feature I want to show you with the next generation protocol framework is the incrementing tool, the pattern tool at the top of every grid. So you can see here in the device there's a blue row here, Ethernet there's a blue row, IPv4 there's a blue row, which is a pattern tool for all of the devices in the device group. So let's configure our IP addresses using this new tool. If I click on the top row, I see there's the tool, and I'm going to put in my first IP address, 51.4.1.2, and I'll increment by 1, and my port step is as shown. So what you're going to see here is that with this tool I can increment all the devices in the device group across all the ports. So it's a very nice tool for that. And I'll show you some other features in it in a second. Let's do the same thing for, I don't want to increment that at all. It's a gateway, but I do want to increment the port step. And so I have that there. So now I see all of my configuration is done, and it should be very easy to see if we can ARP once we start the protocols. Ethernet looks good, device looks good. The other thing to notice here is that if I were to change the multiplier, so my pattern tool is already there, and my pattern is from 2 to 11 on each port. If I were to change the multiplier to 100 for each port, it's the multiplier, the incrementing tool is automatically going to give me 100 addresses per port in order, and everything's going to be configured for me. So it's very easy to scale using the multiplier up and down, and one thing, and secondly, the incrementing and the pattern tool is very useful, and to go across all devices and all ports in the device group. A couple other quick grid functions here is if I make a change to the pattern, let's say I make this 8, it'll show me here that this particular value is out of pattern, and the very top row of the pattern will show the same thing. So if I do have to make some customized adjustments, I can, and it'll show me a little value here that this is not part of the normal pattern. If I made a bunch of those changes and I want to send them back, I just click on that again, it sets them all back. Okay, now let's move on to the next chapter where we will start the protocols and look at status and statistics. Okay, in this chapter we're going to look at the NGPF protocol status and statistics. We're going to take our existing configuration, we're going to start it, and we're going to see all the visual color coding that comes along with it, how to start it at the very granular per session level, as well as at the very high test level and everywhere in between. We're going to watch how you make changes on the fly, restart failed only sessions, and basically all the new granular protocol options that are available for each and every session. We'll also look more down in the statistics layer and look at the real-time statistics, the drill down statistics, aggregated and per session. Okay, we're back in the GUI now, and I've actually taken the 4 ports that were in the IPv4 topology 1, and I've taken 2 of those ports out and put them in their own topology. Now the reason I might need to do this is because of 2 things. Number 1 is I have a different multiplier, so for some reason I want these 2 ports to only have 5 IP hosts, and I want these 2 ports to have 10. So therefore that they must be in separate topologies. Or the second reason I would have to do that is because maybe topology 2 has different protocol requirements. So maybe this needs IP and DHCP in this topology, either in 2 different device groups or in the same device group. So that's another reason I would have to have separate topologies. But there isn't a reason I did this, and I'll show that to you a little later. But right now we want to show you the protocols, what they look like when they're running. So shown in the screen below here, I've clicked on device group 1 and the IPv4, and show you how to start those at different levels. First of all, if I want to start it one at a time, I just click on the button there. I can start the entire stack either by clicking right here, which will start everything in the IPv4 device group, and you can see right away that the Ethernet went to green, the IPv4 went to green, all the sessions went to up, and the gateway actually shows right there in the grid the MAC address of the gateway. I could also start one stack at a time. For example, if I just stop this stack, I can just hover over the Ethernet and start that. Now, since this is basically a layer 3 stack, it doesn't really do anything, meaning I don't send out any frames, but I can go back up to the IPv4 stack and start that, and that'll also start the IPv4 stack. Also note that if I want to just start the IPv4 stack, or whatever the highest stack in the device group, it'll automatically start the lower stack at the same time or right before it starts the stack that I've chosen to start. If I just go over here to my topology 2, I can start at that device group level, or I could go to the whole topology where you might have multiple device groups and start there. So let's just try that one. Click on the device group there, go over to IP, and we'll see that the 10 IP addresses in that topology have started. And lastly, the other ways to start it is at the up here on the ribbon bar. I can start the started device groups that I've selected, or I can just start all the protocols with this drop down. And if you click in the white space here, you'll see I can start the topologies of the device groups from here. To see kind of the aggregated status, obviously if everything's green, that means everything is up. But if you want to see aggregated status, you could always click on the device group, maybe on one of the stacks, and if you collapse it to just show the port level, you'll see that first of all each port will tell you how many are up, and also at the highest level tell you how many are up. So just to show you how the color coding works, obviously green is fairly obvious. If all sessions are started and up, then they're all green. If for some reason you made a mistake maybe when you first started it, let's just change this to 1 and hit OK. First thing I want to show you is while the protocols are running, if you make a change in the grid, the bold thing here shows that it hasn't been applied yet. So when you see the bold, this green apply button will come on, and this is how you make changes on the fly. So the sessions are up. I'm going to apply the changes to have an incorrect gateway, and what you're going to see is that they're all going to go down. So basically now you can see the status of the IPv4 went to red. The green is still there, but for the Ethernet, but all of the sessions are down. If you want to get partial sessions up, I could fix this, go back to 51 here, so they're all correct, and maybe change one of them to an incorrect, hit apply, and now we see that all but one are up. So you can see obviously which ones are up and which one are down. If I collapse them, I can see that this one actually has the down session, so I can drill into that. It gives me the reason it failed, and I also see that the IPv4 stack is yellow, meaning there's at least one session that has a problem. The other thing to note is if I stop a device group, the gray color coding just means that the sessions are not started. Okay, I forgot to show you one thing earlier, which is protocol stacking. Protocol stacking is very easy in the NGPF framework. I can go to this IPv4 stack and add another layer. Here's my layer thing. Actually, I can go to any stack and add a layer. If I go to Ethernet stack and add a layer, it'll show me the available stacks. I might say IPv6, and now I have dual stack hosts with one MAC address and two IP stacks. I'm just going to delete that one very simply and easily. And what I want to show you here is how to add a stack on top of IPv4. If I hit the Add Stack button, it'll show me the available stacks. Right now it's just OSPF and DHCP server. I want to add OSPF stack. It automatically adds it for me. It gives me the default router configuration, the default interface configuration, and it's all done for me. I know my IP layer already works. I can even start that if I want to, just to make sure that my IP layer started. It did before, and it still does. But if I want to add routes to that OSPF routers, now I have 5 OSPF routers, I can just click the Add Routes. I want to add IPv4 prefixes, which are routes. And now I have my network group with a certain number of routes. I'll say I want 10 routes per router. So now I have 2 ports, each with 5 routers in this case. I changed from IPv4 hosts to OSPF routers, and then each of those for a total of 10 routers, and then the 10 routers with the 10 routes each gives me 100 total routes. I can see my route range here. If I want to change something like prefix length, I can, and I can see how the route ranges were distributed across the routers, and I can see my first address, my last address, and the count right there. Now, just as easily, I can click on the device group, hit Start Protocols, and see if my OSPF routers come up. I knew that my IPv4 stacks would come up because I saw that earlier, but let's go down to the OSPF routers that are not up. The interfaces are not up, but I can see status here right in the configuration grid. The neighbors are not in the full state. Actually, I see my problem now. My area is actually 4, so I'm going to change that to 4. It goes bold, meaning I have to hit the apply button for on-the-fly changes. And after I change them to 4, I'll wait to see if the OSPF sessions come up, and sure enough they do. So what's nice is I get all the status and state information right here in the configuration grid. We haven't even gone to the statistics grids yet. This is just full status, DR other state, and any information, typically if it went down, if it's down is where you get the information here. But I can see now that my OSPF routers are up, and obviously my routes have been advertised as well. The NGPF framework also allows for a lot more per session granular protocol operations. For example, for these OSPF sessions that I'm showing now, I can right mouse click and do something like stop hello messages, resume hello, abort the session, get learned info, just for that specific session. So for example, if I stop hello here, we should see in about 40 seconds, which is the dead timer for the protocol, the session go down. So I'm going to stop that, and then we'll wait 40 seconds to see what happens. And sure enough, the session did go down. The neighbor is not in full state. The neighbor state is initialized, and we can now resume, and it will come back up. And there we go. Another operation here is, as I mentioned earlier, getting the learned info. I've already turned on allowing learned info on session 1. So if I come back to session 1, right mouse click and say get learned info, it'll show me the learned info for that router. I can even refresh the state right here. So it's a new view to look at all the different learned information for that router from the DUT. These operations are also under actions here at the top, so you have those available on the ribbon bar. And the final thing the NGPF framework gives you is protocol options. So now under the protocol options, you can see that for Ethernet and IP and OSPF, we have all the rate controls for every protocol and every port. So we see the start and stop rate of the protocol sessions for IPv4. You can also have the ARP rate, the start rate, and the stop rate. So each protocol will also have those options as well. The last thing I want to show you in this chapter is the actual statistics for the NGPF. We have new statistics for NGPF protocols, and to get them, I'm going to re-enable the statistics pane. I'm going to actually minimize, collapse the configuration grid with this button, so I have some more real estate. Pull this up here to see my statistics. So right away, let's just look at all the NGPF views, which are actually already turned on. You can see I have NextGen protocol views specifically for NGPF protocols. I have the protocol summary, so I can see all my IPv4 sessions that are total up and running. I think this one I misconfigured the gateway, and that's fine. And then how many routers I have running. I can also look at the port summary, and I can see how many total sessions are up, how many are down, so I get my aggregated views. From the protocol summary, I can also drill down, much like in traffic statistics. I can also drill down with NGPF. Now these are all real-time views, so they'll go up and down. Let's see if I stop the stack here. We should see this go down to I just lost 20 sessions that are not started, 10 are up, and a total of 30. And then if I click that and start it again, I can see the real time go back up to 29 sessions with 1 down. For OSPF routers, I can just right mouse click just like I do in traffic statistics, and I can say, let's look at the per session stats for my OSPF routers. There was also some other options there. The first thing to notice is the refresh. So all of the per session stats are refresh only statistics. But when I drill down, I can get full status on each of my OSPF routers. How many hellos were sent and received, what's the current status, databases sent and received, and all the rest of the statistics that you might need, especially when you're troubleshooting. As you saw on the config grids a few minutes ago, I get a lot of my status there. There may not be a need to go into the full statistics for the number of packets sent and received for each OSPF session, but if I need that, they're there, and I can just drill down. I can hit the refresh statistics button. It'll just automatically update all the stats. The bottom left here shows the last time since I refreshed, and again I can hit the refresh button down here or the refresh button at the top of the window in the ribbon bar to refresh. And the refreshes are very fast. It's hard to even notice them happening, but you can see a little bar at the bottom as I click here. The last chapter in this IxNetwork video tutorial is building traffic using NGPF endpoints. In the traffic wizard, there's a new endpoint selection tool when you want to select devices and sessions within the device group or within the stack. If you want to select the entire stack, that's still a single checkbox, but there's a new tool if you want to drill down into endpoints within that stack. We're going to cover how do you send traffic from sources and destinations using the NextGen protocol framework endpoints. So in this case, we have 100 OSPF routes and 20 IPv4 addresses on 2 ports over here and 2 ports over here. So we're going to figure out how to send traffic to these using the traffic wizard. The traffic wizard is basically the same as before. There's only one difference, which is in the endpoint selection page, which is the first page. All the other pages are exactly the same. So first thing we're going to see is when we go into the traffic wizard, we're going to see our topology and our names. This is why it's important to name the topologies and the device groups with a certain name so that you can know what you're looking at when you get into the traffic wizard. So let's expand those, and in this case, let's go from the OSPF route ranges. So if you remember, we had 100 route ranges as the source. And as a destination, let's go to the 20 IPv4 addresses on those 2 ports. So from 2 ports to 2 ports, go down to tracking. Let's just select source destination value pair, which means source destination IP pair. Hit finish and start. And what we're going to see in the traffic item first, of course, is the first place you want to go to see if there's any high level loss, and there's not. So no loss. Latency is about 8 microseconds, and let's look in the flow stats. And this is what we expect, right? From port 3 is going to port 1 because we had one-to-one mapping in the traffic wizard, and from the routes on port 3 to the IP addresses on port 1. So that's exactly what we're getting, 100 rows, 50 routes to the 10 IP addresses on port 1 from 3 to 1 and from 4 to 2. So that's pretty straightforward on sending traffic. But now what I really want to show you is how to send traffic to a subset from 3 to 1 and a subset from 4 to 2. So not the entire range, but a subset of that. Let's stop traffic. Go back into the traffic item. Double click. Let's just go ahead and delete that endpoint set so we can start again. And this time, why don't we go from only the first 10 routes in each of the ports. So instead of all 50 and 50 to 10 and 10 on the other side, let's go just 10 routes and 10 routes on ports 3 and 4 to the 10 IP addresses and 10 IP addresses on port 1 and 2. So to do that, you still go into down to the IPv4 prefixes, which is all 100 routes here. And if you want to select them all, that's what we just did. If you want to select a subset, you got to go into here. So this is the new endpoint selection tool. By default, since we selected the checkbox before we actually went into it, um, it's actually showing you all 100 addresses will be selected. If you want to select a subset, you can use the drop down here and say, well, what's my first port that I want to start with? I'm going to go 3. Yeah, I want both ports to do that. I do want to start at the first address as my source from port 3. But I only want to do the first 10 addresses on each port. So when I do that, it automatically selects my last address on that port 3. And it also selects the first 10 on port 4. So the bottom portion of your screen is really just a graphical representation of what part of the endpoint did you select. So I've only selected really I guess the first 10 out of 50, so that's 1/5 of the addresses on port 3, which is the top row, and 1/5 of the addresses on port 4, which is the bottom row. And that's just a representation of what I selected. Another way to do this, if you wanted to, you can certainly add more, and this would be just a different way to do it. Let's just do the first one is port 3 and the second one is port 4. You put 10 on each, and that basically accomplishes the same thing. The reason that we had to do it in this particular format is because in NGPF framework we're able to do tens and hundreds and hundreds of thousands and millions of rows in the GUI. It's a very scalable GUI, but the traffic wizard itself is just not easy to scale to a million rows. So it's a much easier way actually to select ranges of endpoints with this tool than it will be to scroll up and down in the traffic wizard. So it's actually a better way to do it. You just have to get used to it. So you just select OK. So as you can see, I've only selected 20 addresses. It does give me a readout there. And then I go over here to IPv4, and I can just select them all because I don't, there's only 20 there, so I'm going to go 20 to 20. If I wanted to go a subset, I could just again click here and then do the same thing as I already did for my destination, but I don't need to do that. So I just add that as before. My flow tracking is still there. If I want to see my preview, I should see, and I do, only the first 10 addresses, the first 10 routes going to the 10 addresses on from, this would be port 3 to 1, and then on port 4 to 2 you have the first 10 routes to the 10 IPv4 addresses. Finish and start. And there you go. There's my 20 rows. 10 of them from port 3 to 1, 10 of them from 4 to 2. There's my source destination IPs, and I'm getting no loss. So that concludes the video tutorial on the next generation protocol framework introduced in IxNetwork 7.0. Thank you.